honored to have one of our own, Bill Green, back with us again. Bill has been doing sort of an annual update and presentation to us on space and space exploration and all that's happening in space. For those of you who don't know, Bill is spent most of his engineering career at JPL and Caltech, managing teams of scientists and engineers, processing images returned from space telescopes, spacecraft that explored planets and moons, landers and rovers on Mars. He helped us with a JPL tour a few years ago, actually right as COVID was hitting us. He's currently consulting on a mission that will launch a telescope designed to find large asteroids that might impact Earth. I hear we just have a few years to wait before one hits us, so they can be deflected before they impact Earth and cause severe changes on Earth. So Bill, welcome back, and we look forward to hearing from you today.
Thank you. That one's not going to hit us, as far as everybody knows, but it's getting uncomfortably close. I started putting this talk together, and I got into the folder on my computer where my space talks are, and I'm looking, and I'm going, oh my God, I've been doing this for a long time here. And I counted, and this is my 13th annual Hazak talk on space exploration. So welcome, and your quiz is going to be, what do you remember about the talk in 2014 about the Chinese space program? That was one of the most fun talks I ever put together, because nobody knew the Chinese were thinking of having a space program. And everything I found in the research for that talk has actually come true. They have their own space station orbiting the Earth. They've gone and sent a lander to the backside of the moon, picked up samples, and returned them to Earth, and we haven't done that yet. Even Elon Musk has not done that yet. So, you know, they're pretty serious about their space program, and you heard about it here about 11 years ago. Anyway, if you remember any of these, they were kind of fun. Planetary defense in 2019 is when I got involved in missions involving finding asteroids that were threatening, and so I started talking about asteroids, and you've seen that woven into some of these other talks. So anyway, it was kind of fun to see. It's my bar mitzvah year here. Okay, today we're going to talk about four things. We're going to talk about mankind's fascination with Mars, and is it really realistic to send humans to Mars in the near future? And I'll let you define the near future. I'm going to talk to you about two different women who are famous astronomers, Nancy Grace Roman and Vera C. Rubin. And I'll tell you about both of their careers and why two major missions, two major telescopes are being named after each of them. And then I'm talking about a mission that launched last October, and it's going to one of Jupiter's moons named Europa to do some research there and see if there are really oceans under the surface of that moon of Jupiter, which it looks like there are. So that's kind of where we're going today. Start with Mars. And the real question is, how realistic is this picture? And when is it going to be a realistic picture? So let's talk about some of the issues about going to Mars if you're a person instead of just a spacecraft. Why has it been so fascinating over the years? Well, you know, it's an orange object in the sky that comes and goes with the seasons and the years. And that's kind of weird, an orange dot in the sky. The rest of the sky doesn't look orange, the objects in the sky. So then people who started looking at the surface of Mars with telescopes thought they saw things on their sketches when they were sketching what they saw on their telescope. They started drawing, you know, like freeways and channels of what they thought was water and all that kind of stuff. And they inferred that there was intelligent life on Mars building a society there like we have here on Earth. And then in 1960, we sent some spacecraft out and got closer and closer to the planet and discovered that those were, you know, not really freeways, and they weren't really cities and things like that. They were just craters and volcanoes and canyons and things like that. And more recently, we've sent rovers to the surface, and we've got them collecting things and looking at things and acting like little Mars geologists, poking around and seeing what things are made out of to see if there's any possible sign of life sometime in the past history of Mars, going back a long time. And what's really motivating a lot of the solar system research now is a search for water. Anywhere it's possible to find water is of interest to astronomers, and the Europa mission we'll be talking about today is one of them. But anywhere there looks like there is water or there used to be water is very interesting to the astronomers who are trying to figure out, is there life now, or was there life there sometime? Or could there be life later? Okay, so let's talk about Mars and Earth and their relationship. We're neighbors in the same solar system. We're orbiting the same star. How long does it take the Earth to orbit the sun? Well, it takes 1 year, because that's how we define what a year is. If you look at Mars, Mars is further from the sun, so it takes longer for Mars to orbit the sun than it takes the Earth. It takes, as a matter of fact, about 2 Earth years. So every couple of years, Mars and the Earth are on the same side of the sun, and every other year they're not. They're on opposite sides of the sun, which makes it very difficult to communicate if you're trying to communicate to Mars from the Earth. Some years it's easy, some years it's not. If you're trying to get to Mars, some years it's easy, some years it ain't. And the other interesting thing is the orbit of Mars is not as circular as the Earth's orbit. So the distance between the Earth and Mars changes from year to year as we pass each other in the sky. So here's sort of what, looking down on our solar system, sun's in the middle, Mercury and Venus toward the sun. We're there in our little 1 year orbit, and there's Mars. Happens to be the year that Mars is near the Earth. The next year, if you look a year from now on this picture, Mars will be on the other side. So how do you get to Mars? Well, the way the missions that we are sending get there is you sort of launch when, let's see here, Mars is down here on the outer, I don't have a pointer. Can you see that on the screen? Okay, good. So here's Mars out here. Here we are. What you do is you launch around here and you catch up to Mars as it's in its orbit like that. And that typically right now is taking 9 months. Could go a little faster, you might miss it. Could go a little slower, you would not get there. Last September was an interesting time because it had been 60,000 years since our planets were this close to each other, because that was a year that Mars was closer to the Earth when it passed by at the same time we were on the same side of the sun. So that was interesting. 100 years ago, 1924, people were going crazy because the astronomers were telling everybody Mars is going to be as close to the Earth as it's ever going to get for another who knows how many million years. So people began getting interested in Mars. People dragged out telescopes to look at Mars as it got closer. You have a combination here of an astronomer on the left and an engineer in the middle, and that's always a very dangerous combination. So what they did was, and it turned out somebody had built a radio receiver for the military at that time, and it looked like that thing on the bottom, and they began pointing those kinds of receivers at Mars, and they thought they were getting radio signals on the right, which some people thought showed faces, just like people's faces. And so everybody was really excited that on that particular day, when it's as close as it's ever going to be for many thousand years, maybe we can learn with telescopes that there are really live people, and maybe they'll signal us on the radio receivers. And so there were people that thought, yes, they were signaling, or no, they weren't signaling, and that went on around the anniversary of that thing. So that was 100 years ago. People are always interested in Mars. If we want to go to Mars, okay, what do we need? Well, we need at least 9 months to get there usually. If you want to get to Mars, you got to stay on Mars. I mean, you don't want to go and kind of pass by and come back again. Spacecraft are doing that, but, you know, we're not too interested in doing that. So you need to live on the surface. Well, how long do you have to live on the surface? Well, you start computing. Okay, if it took 9 months to get there, and we're going to land on the surface, and Mars is going to be on the other side of the sun for a year, and it's going to take us maybe 8 or 9 more months to get back, you need to stay on the surface for a long time. So you need stuff if you're going to stay on the surface. And you need a place to be that's like a habitat, like in the movies that you've seen. And you need stuff. You need food, and you need oxygen, and you need phone chargers, and, excuse me, toilet paper. And for who knows how many months, because I haven't figured this out, and I haven't looked up if anybody, I mean, other people have figured it out, but I thought it wouldn't be useful anyway as far as this talk goes to know that. And then you got to get back, right? So you got to have a vehicle that can launch from the surface of Mars and maybe meet up with another thing that could get back to the Earth and transfer the astronauts to that, and then have them fly back to the Earth in about 8 or 9 months or 10 months, whatever it takes. That's what you need to do to put people on Mars and bring them back, assuming we want to bring them back. Now, that's a whole other conversation that you can have that conversation with Elon Musk, because he wants to establish a city on Mars, and that's a whole other story. Okay. The other thing that's an issue is radiation. Okay, now the radiation environment in space is really beyond dangerous. We get a lot of protection here on Earth from the stuff that the sun is spewing out into the solar system. But if you're out there like the space station has huge amount of shielding on it to protect the astronauts from the radiation they're flying through every single day out there beyond the Earth's atmosphere. We'll talk about the Europa mission a little bit later. It's interesting because from this aspect, it's going to one of the worst radiation environments in the solar system. So they've had to design that mission so that the spacecraft itself with its electronics could survive long enough to be able to return some really decent data. So we'll talk about that in a few minutes. But it turns out to do that, they had to fly the heaviest planetary spacecraft ever flown by us, because they had to shield all the electronics on board of that spacecraft. So radiation is a big deal. This is about 3 years ago in Scientific American. Space radiation limits needed for astronauts, and they actually track when these astronauts go up and they stay on the space station and they orbit for a year or two and they come home. They keep track of how much radiation they've experienced. They actually have little things on their arms that keeps track of the radiation they're getting. And there's an end point for every astronaut to their career if they're going to fly in space. Because of the radiation limits, they're very concerned about having a legion of people with cancer that have flown in space too long. So that's a real concern, and that factors into all the other stuff I said about sending people to Mars, because they'll be exposed on the surface. Our friend Elon says humans can be on Mars in 4 years. He said that last September, so the clock is ticking. I haven't seen, much activity there. He's more interested in other things right now, but anyway. And then he's envisioned people staying on the red planet in a self-sustaining city, no less, 20 years from now. So somebody said, let's send him there. I didn't hear that. That's one man's vision. All right, so leaving that speculation of how long will it take to get humans there, there is a rover on the surface right now. It's this incredible thing that's been running for 3 years and 4 almost. And it's exploring areas on Mars, driving around, looking for signs of water. Because remember, again, the thing the scientists are interested in is water. So they've got instruments on board to look at rock samples, dirt samples, dig down underneath the surface, looking for any sign of an organic material in the crater where it landed. The crater itself was having water in it, as far as they can tell, millions or billions of years ago. So you get organic compounds, and they can be detected by an instrument on the thing called Sherlock. So I'm going to show you the areas that they've been exploring because they're interested in looking for material that's got organic qualities. So here's, let's see, Chania Falls. Okay, that's an area where it's pretty clear there was water shooting down that little path going from the top right to the lower left, and it was carrying rocks and debris with it. And this is heaven for the biologists. They took samples of this. The samples are going to be lying on the ground, hoping that someday somebody will fund the mission that actually will go pick up the samples and bring them home. That's a whole other story, particularly with what's going on now. But at least the stuff will be sitting on the surface, waiting for somebody to pick up and bring back here someday. This is another great area. This is Neretva Vallis. I don't know what that stands for, but it's a huge river channel that brought water into the Jezero crater billions of years ago. And if you look at the crater where this particular rover landed, you can see on one edge of that crater there's a lot of erosion that happened to the wall of the crater. So you got a crater that got formed at some point. Later there was erosion in the crater, and later there was obviously water flow or something carrying all this kind of stuff down into that area. So that's what's going on Mars. We're still waiting to see when people are going to get to Mars and do this, but at least we have robotic explorers that are giving us a lot of data. So that's what's going on Mars. Any volunteers for going to Mars? You can send your name to NASA. They're keeping a list. Okay, I'm going to change gears here. Anybody know who Nancy Grace Rubin was? Anybody in this room? Of course not. She was a very famous astronomer in her time and a very interesting lady. She was born in 1925. She graduated from Swarthmore. She got a PhD at University of Chicago, which was tough for a woman to do at that time. And she had trouble finding a job in astronomy. She could find some level of jobs in astronomy, but nothing to do real research. And eventually she was lucky to get to the Naval Research Lab, who would hire a real PhD astronomer to do research. And then Sputnik happened, and the government got interested in really funding a space program. And so they basically created a branch of astronomy. They needed somebody to run it, and they actually picked a woman to do that in 1961. And she was one awesome lady. She ran the first real astronomy research program for NASA in the 60s. And among other things, she made sure that the Cosmic Background Explorer mission got funded. It was the first infrared astronomy satellite that was actually orbiting around in space. And it became one of the first important discoveries that got a Nobel Prize for finding the cosmic ray background, that you could look further back in the universe and time and see actually the evolution of galaxies and stars billions of years ago with these instruments. And she became a real advocate for the Hubble Space Telescope. Everybody knows the Hubble Space Telescope, right? Been up there for Lord knows how long. That was the first major high resolution at the time space telescope orbiting the Earth. Astronomers would treat it like a ground observatory. They'd turn in a request to do a certain level of research in a certain part of the sky, looking at certain things they wanted to test in terms of their theories. They'd get evaluated every year. They'd get funded or not funded, and then they'd program the spacecraft up there that's up there today, still taking data for astronomers and publishing papers and finding out all kinds of stuff about the evolution of our solar system particularly, and the rest of the universe while they're at it. So this little, I think this is a little video about her.
What lady would take mathematics instead of Latin?
Nancy Roman has lived an extraordinary life. A talented astronomer, NASA's first chief of astronomy, and a lifelong champion of women in science. She even became the mother of the Hubble Space Telescope. Nancy Grace Roman was born in 1925 in Nashville, Tennessee, the only daughter of a music teacher and a geophysicist. Though her father was a physicist, it was Roman's mother who awakened her interest in astronomy.
I've been interested in it as long as I can remember. I blamed my mother because she used to take me out and show me the constellations and show me the northern lights and things like that.
This early appreciation of the night sky sparked a lifelong passion. By the age of 11, Nancy Roman had already formed an astronomy club and began to study astronomy on her own.
I think I've always been curious, and I just wanted to satisfy my curiosity. Astronomy in particular was a subject I wanted to learn more about.
Nancy followed her dream and became a professional astronomer, working in the new discipline of radio astronomy. And in 1961, she became the first chief of astronomy in the Office of Space Science at NASA, the first woman to hold an executive position in the agency. At NASA, Nancy Roman was instrumental in developing the first space observatories and in paving the way for the most famous orbital observatory of all, the Hubble Space Telescope. Other scientists had proposed the large space telescope, but it was Nancy who made it happen. She brought together astronomers, NASA engineers, and the cutting-edge technology.
And engineers and scientists don't talk exactly the same language. They have a different job. Astronomers, well, scientists in general are trying to understand why. Engineers are trying to understand how. And I found myself actually acting somewhat as an interpreter between them.
She united not only scientists and engineers, but also those who would fund Hubble. Nancy was able to convince politicians that NASA and ESA should join forces and work together to realize a large space telescope. All of Nancy Roman's hard work paid off in 1990, when the NASA-ESA Hubble Space Telescope took to the skies and began to unveil the universe in greater detail than ever before. For her achievements and her determination to bring young women into science and engineering, Nancy Roman has been honored with medals and awards. An asteroid was named after her, and she even appeared in a Lego set. But Nancy Roman's greatest legacy may be Hubble itself. Even after 28 years, this telescope continues to give us a unique view of our beautiful universe.
Yeah, quite a lady.
What lady would take?
So the telescope that's being named after her is designed to talk more about to investigate more about what's called dark matter and dark energy. We'll talk about that a little bit more later in this talk. But it includes something called a coronagraph that's been developed by JPL in Pasadena. And what a coronagraph will do is if you're looking at a star with a very high resolution camera out in space, you want to block the starlight up to a certain point so that you don't overexpose the image and you can see the detail in the atmosphere, the fuzzy atmosphere that's surrounding the star that looks like our sun. So you want to block, if you're doing it from the Earth, you want to block the sunlight to take a look at what's going on in terms of solar flares and stuff like that blasting off the surface. So it's going to fly one of those along with the basic camera, which will be looking for the chemical composition of very, very distant stars and objects, and be looking for possible signs of life. So it's just a natural, it's an extension of the work that she started by getting the Hubble Space Telescope funded, and be a good project. It's going to launch in 2027, we hope, right now. Here's a video about that mission.
The universe. For all we have learned about it, we have only just begun to reveal its secrets. What are dark matter and dark energy? How common are planetary arrangements like our own? And how many planets in our galaxy have the potential to harbor life? The Nancy Grace Roman Space Telescope will help answer these fundamental questions. Formerly known as WFIRST, the Roman Space Telescope is similar to Hubble, but with the benefit of 30 years of technological improvement. Each image from its wide-field instrument will have the depth and clarity of Hubble's best, but capture a sky area 100 times larger. The Roman Space Telescope will take the lead in exploring dark energy and dark matter. We only know they exist by their effects on observable matter, yet these two mysterious components make up 95% of the universe. The Roman Space Telescope's powerful 2.4-meter mirror and enormous field of view will also help us in the search for planets beyond our solar system, or exoplanets. It will watch for gravitational microlensing events, caused when a planet and its host star pass in front of a background star. Such events are rare, so catching them requires watching large swaths of the sky. To deepen its study of exoplanets, the Roman Space Telescope will house a beyond state-of-the-art coronagraph that will directly image and analyze Neptune-sized planets in orbits slightly larger than Earth's, a dramatic improvement over current capabilities. The Nancy Grace Roman Space Telescope will help us answer many of the biggest cosmic questions. Its wide-field view and coronagraph will complement missions like NASA's James Webb Space Telescope and transiting exoplanet survey satellite TESS. The Roman Space Telescope will be an indispensable part of space science during the next decade and beyond.
Okay, so that's coming down the road. It's under construction right now. There's part of the telescope in assembly at Goddard Space Flight Center in Maryland, outside of Washington, and it's coming together. Okay, so that's part 2 for today. Part 3 is a mission called Europa Clipper, and it was launched and is now on its way to Jupiter. Jupiter, in case you haven't counted lately, has 95 different moons. They're small to large. Europa is one of the large ones, one of the first discovered. Galileo actually discovered 4 of Jupiter's moons. They're called the Galilean moons in 1610 when he built his telescope that was strong enough to be able to see those moons as dots orbiting Jupiter. So he'd look at Jupiter, and some nights he'd see them there against the sky, and other nights they'd disappear behind the planet. So he knew they were orbiting, and he discovered the first 4 of Jupiter's moons. Europa is one of those. And we got a little shot of it on an early mission that just flew by at high speed past the outer planets, and it went by Jupiter, and they got a couple of shots of Europa as they went past Europa. And it showed a bizarre surface, quite different than our moon. And there's Galileo trying to explain it all to the church right before he got thrown into prison for doing this, if you remember that story. This is one of the pictures from a later mission, Galileo, which orbited Jupiter for about 6-7 years successfully. Once they got a lot of data on Jupiter itself, they began looking at the individual moons. They looked at Europa, and the surface doesn't look anything like the Earth's moon. It's a pretty large moon, and this is a piece of the surface that's 10 by 7 miles. And if you look at our moon on the left there, you'll see the typical craters that we're used to seeing when they show pictures of our moon. This surface is totally different. There are some craters visible. They're in astronomical time, relatively recent, but mostly it's a fractured and serrated surface. And the theory is that there's an ocean sloshing around underneath this surface. And so Europa Explorer is being sent there to determine, or Europa Clipper, excuse me. It was launched in October. Has 9 different science instruments. And actually, it's going to be in orbit around Jupiter, but they've designed it because of the radiation. When you get close to the planet, you get this huge, it's probably the most radiation condensed in one area in the whole solar system that's flying around Jupiter. So it's a very dangerous place to fly if you happen to be an electronically powered spacecraft. So what they do is they orbit Europa, and they put it in an elliptical orbit. I don't know if you can see that here very well, but it's kind of an elliptical orbit, and they go up and around, and they take a shot of part of Europa and get the heck out of there. And they're going to be doing this for several years. They're going to be doing 50 flybys, and as the moon turns underneath the orbit, they'll be able to cover a good part of the surface. And that'll protect as best they can the spacecraft components from the radiation environment. So Europa shows signs of a crust. The theory is there's an ocean of liquid water under there. The crust might be thick ice for a while, but then it warms up and it melts, and there's water under there, and then a surface under that, hard surface. And that's what Europa's going to find out. So they're thinking, well, it's got an outer shell of ice, a surface that looks like you saw, and maybe we'll see plumes of material venting from underneath the surface. That's happened on several different moons we've seen of Jupiter and Saturn both. And so this is the theory of what's underneath the surface. There's that surface on top. Here's ice, and then it melts as it gets warmer, and then maybe a hard surface underneath that. And this is a NASA video about the Europa Clipper mission.
The most exciting thing about Europa can be summarized in one word: water. Now think about all the water on Earth, and double that. That's what we think is on Europa.
We need to go there to explore it, to understand, is this place a habitable environment that could potentially support life?
Getting close to Europa is a huge challenge. It sits in the worst possible radiation environment, trapped by Jupiter.
Europa is a moon of Jupiter, about the size of Earth's moon, which has an icy surface that probably hides a subsurface ocean.
Scientists think Europa has the key ingredients to support life as we know it. Number 1, water. Number 2, energy. And 3, essential chemical building blocks. For the first time ever, we're sending a spacecraft completely dedicated to studying this moon.
The 3 main things that we're going to explore at Europa are the ice and the ocean, and understand that intersection between the two. Study the chemical composition of the moon, as well as the geology and whether it's active currently.
Europa Clipper is not specifically a life search mission. We're going to understand the potential habitability of Europa. The spacecraft has 9 instruments and a gravity science investigation. 5 of the instruments are called remote sensing instruments because they measure light reflected off Europa, like a camera or a spectrometer. The other 4 instruments are measuring the environment around them, like sniffing gases or dust.
Europa Clipper is the largest spacecraft NASA has ever built for a planetary mission.
It weighs 13,000 pounds, 6.5 tons. That's like the size of a huge African elephant.
And the solar arrays are massive. If you put the solar arrays at the toes of the Statue of Liberty, the other end of the arrays would come up to the Statue of Liberty's crown.
So not only are they big, these things are technological marvels. They are being bathed in radiation all the time, and they have to survive the entire mission like that.
Jupiter's radiation environment is intense, and Europa sits in the worst part of that environment.
Jupiter acts like a giant particle accelerator. There are charged particles trapped in Jupiter's magnetosphere that rotate with it. And these particles slam against Europa and will slam into our spacecraft as well.
We protect the spacecraft in 2 ways. Number 1, we try to minimize the amount of time we spend in there, which is why we are orbiting Jupiter and just flying by Europa. The second way we protect against the radiation is by having an electronics vault that we put our computer and some of the other sensitive electronics inside, which is made of about 1/3 of an inch of aluminum.
With each flyby of Europa, the outside surface of the spacecraft sees the equivalent of 1,000,000 chest X-rays, just as we're flying by.
It's a pretty long trip to get to Jupiter from Earth, but not that bad from a planetary standpoint.
From launch to the time we get to Jupiter is about 5.5 years. And along the way, we have a flyby of Mars and then another flyby of Earth to get gravity assists to slingshot the spacecraft out to Jupiter.
I hope for the future explorers who are watching this at home that they take away from this that humanity, when we come together, can achieve really cool things.
This mission has been a long time coming, and we're so excited about what we're going to see when we get there.
We are in a golden age of robotic spaceflight exploration. How could you not be excited about something as monumental as this?
I am most excited about the potential to unlock the secrets of Europa, the potential to really understand this crazy world that exists and has likely existed in this condition for 4 billion years.
So you want to find a group of people that enjoys their job every day?
The most exciting thing...
That's one of them. This is a picture of the solar panels as they were in assembly before they got attached to the spacecraft. They get folded up for launch, and then once a spacecraft is released from its boosters, it's out there in space, then they unfold the solar cells into their final configuration that you saw in the pictures. And that all went really very smoothly, so everything's on track. I think their first Earth flyby happens sometime, I think, in the next year, so you'll probably hear about that. That's an attempt to just speed up the spacecraft a little bit more. As it swings by the Earth, it picks up another boost. So that's it. Okay, we're going to move on to Vera Rubin and the world of dark energy. Okay, Vera, similar to Nancy Roman, parents were immigrants here. Father helped her make her first telescope. She was an astronomy major at Vassar, the only one actually. She got to Princeton. She got a master's at Cornell and a PhD at GWU, 1954. Her research was in the motion of distant galaxies. And what she was finding, along with several other astronomers at about the same time, is that as you look deeper in space, you see how these galaxies are behaving. Galaxies are, collections of stars that are in spiral formations or circular, and they rotate very fast, so they should be flying apart because they're spinning in space, and they shouldn't be holding together the way they are. And nobody literally nobody knows why that is. They don't know what's holding these things together, even though they're rotating so fast. If you do the mechanical calculations, these things ought to be flying apart, and they're not, as far as we can tell over time. So that's where the idea of dark mass or dark energy comes from, is there's something out there that we haven't discovered yet. And this mission is designed to do more research to try and discover what the heck is holding this whole system together. Be nice to know. And the other interesting thing about her was she was the first astronomer who was a female allowed to observe at Palomar Observatory down near San Diego. When she got there, she discovered there were no women's rooms in the monastery, which was a building at Palomar that was famous where all the astronomers would sleep during the day and then go out and do their observing at night. And in that building, there was no women's room. And so she raised Cain, and there are now women's restrooms at Palomar. So she has a lot of different heritages. Also another interesting person. Oop. I guess that's not a video. I thought it was. Okay, so here's the Vera Rubin. Now it's a ground-based observatory. It's not out there in space. It's actually on the top of a mountain in Chile. Chile is 8,700 feet high, this particular mountain that they selected. The mirror on this telescope is going to be 27 feet in diameter, if you can think about that. And it's going to be reflecting light into the biggest digital camera ever constructed. It has 3.2 gigapixels in the camera system itself. If you know a megapixel, okay, you keep going, you get to gigapixels, and you get to, anyway, it's a whole number system there, but that's a lot of pixels. And it's so many pixels that the entire sky will get photographed every few nights. And first light, they're expecting this August, so you'll probably hear about that. It's funded by the National Science Foundation and managed by a group that manages other observatories, ground-based observatories in the US and elsewhere. And they're going to be releasing this data to the public. So if you've got a computer at home and it can handle a few terabytes of data, it'll be there for the taking every day. This is the Vera Rubin telescope on its mountain over here. There's another telescope called Gemini, which is observing in other wavelengths. It's been operational for just about a year now. This monster is going to be something. So I got two videos, one on the telescope and one on the camera.
This is the Vera Rubin Observatory. When it opens up, this telescope's going to be looking at the entire sky from the southern hemisphere. Previous all-sky surveys have taken years, months, and even weeks to complete one survey of the sky. This telescope's going to do it in a matter of days. This telescope's going to survey the entire sky over a period of 3 nights, for 330 days of a year, over 10 years, to complete the legacy survey of space and time, which is going to completely change how we view the universe. The telescope has a unique 3-mirror system, which is going to enable it to see more of the sky. The real 8.4 meter mirror is in a warehouse outside, but this is a surrogate mirror that they've been using to test. And when the real mirror comes in, it's going to be coated in just 16 grams of silver in this machine here. The main thing that's not here yet is the camera, which has been built at the SLAC National Lab in the US.
We got the 3.2 gigapixel camera. They have 2 Guinness records, the biggest one for the biggest camera, and also the one for the biggest lens.
The entire telescope weighs 100 tons, and it can move to any point in the sky in 20 seconds.
The telescope moves really, really fast. It's incredible. It's faster than any other optical telescope in the world.
The telescope over its 10-year lifetime is going to produce 60 petabytes of data, And every evening it has to transport that data all the way to the nearest town and then to the US.
One of the most challenging parts was to install the fiber through all the building, from the data center in the second floor to the telescope in the 8th floor. It was around 150 meters of fiber, and put the fibers inside the telescope and go to the top of the telescope. That was really hard. The data will be public almost 2 days after, so everyone all around the world can be discovering new things.
The Vera Rubin Observatory is going to see 10 million things changing in the sky every night, which means that every night we'll have a chance of seeing a 1 in 10 million event happening. Because of its unique ability to see things changing in the sky, the telescope's going to be able to provide insight on some mysterious objects that we've seen, like fast blue optical transients. But it's also hopefully going to show us things that we've never seen before, potentially cosmic strings, and maybe even technosignatures, signatures of alien life from megastructures like Dyson spheres.
So that's the telescope itself. And if you remember, in the 60s and 70s, there was a linear accelerator built at Stanford University in the hills up behind Stanford. A long tunnel. They did that for nuclear research. They were shooting particles at material to see what was flying off from the impact, and they needed a lot of impact. So they sent charged particles down these long tunnels. And that institution is pretty much done with that work, but as long as they had a lab and a group of people that could do that, they're the people that are building the camera that goes inside this telescope up in Chile. So this is a video about just the camera itself. Those of you who are home photography fans are gonna love this video.
30 years ago, scientists proposed construction of a new telescope in Chile to survey the heavens. Today, the Vera Rubin Observatory is almost ready to begin its groundbreaking studies. This new telescope on a mountaintop in Chile will be capable of taking pictures of every part of the southern hemisphere sky in just a few nights. To do so, here at SLAC, we have built the LSST camera, the world's largest digital camera, featuring over 3 billion pixels. Together, the Vera Rubin Observatory and the LSST camera will take pictures of every part of the night sky over 3 or 4 nights, and will continue to take such images every night when the weather cooperates for 10 years. By that time, we'll have collected almost 1,000 images of every part of the night sky. And with those images, we'll do 2 things. First, we can combine the images with our computer algorithms, enabling us to see unbelievably dim objects. We expect to see 20 billion galaxies, 17 billion stars in our own galaxy, the Milky Way, and as many as 6 million objects in the solar system. We'll also analyze every image one by one. The data will come here to SLAC, and we'll compare everything we see in that image against previous images taken in that direction of the sky, and we'll flag any changes. We expect to flag between 1 and 10 million objects every night, identifying objects that are moving, asteroids in the solar system, or changing in their brightness, exploding stars, supernovae, distant galaxies, and a whole host of phenomena in between. Together with this groundbreaking new data set, we will enable studies of the expansion of the universe and dark energy, studies of dark matter, which pervades the universe, studies of our own galaxy, the Milky Way, to try to understand how it formed, as well as more detailed studies of the solar system, to see how our planets and our cosmic neighborhood developed. In addition, this fantastic data set will be available for the entire US science community and international partners. Everyday people who are just interested in learning more about the heavens will be able to look at our data as well. We're truly excited to begin observing with the Vera Rubin Observatory.
Those numbers just blow my mind. I don't know about yours. Just cannot imagine. Okay, that's enough for one day, right? Oh my God.
Okay.
I have 3 questions. One question is, what causes this high radioactivity at Jupiter? The second question is, could there be any other explanation other than water that would cause those canals that we see on Mars? And the third question is about those 2 astronauts
Everybody always asks about the 2
that are
astronauts, right?
stuck up there. Why can't they come home?
Okay, let me back up again. Your first question was, real quick. Oh, the radiation. It's coming from the sun. Okay, the sun is out there and it's spraying stuff every moment, and it's all going out there, and it ebbs and flows. You know, when it's really bad, it'll disrupt communications here on the Earth. They'll they monitor sunspot activity to know when these things are coming, and it's out there all the time. And that's true of every solar system out there that's orbiting a star.
But why is it so much higher at Jupiter than here?
Because Jupiter is this huge mass of material. It's 12 times more gravity than the Earth has, so it's sucking up more of it as it's going flying by. And your third question
Any other
was?
explanation than water?
Oh, well, maybe, but probably not. I mean, this has been going on for like 30 years now on the surface of Mars, and pretty much the conclusion of every mission that's gone and taken samples is this had to be water flow.
Who's next? Oh, the third question was about the 2 astronauts.
Oh, the 2 astronauts. I don't know what's going to happen with the 2 astronauts. I mean, they'll get down eventually. It's not a big deal. They're perfectly safe up there. They wouldn't be safe if they sent them down in the wrong vehicle. So, and you know, there are 2 ways to get down. Either they get down in a U.S. spacecraft that's shuttling people back and forth, or they get back with a Russian spacecraft that we're paying the Russians for, heaven help us, to get our astronauts back and forth. And it'll be one of those, and that decision is based on God knows what. But they'll get home. They'll get home. Yeah.
Yeah, the study of Europa, the benefit will be what? Obviously, it's too close to the sun to inhabit by humans. So the benefit of confirming the existence of water there is what?
Yeah, it's the existence of water, number one, and is the theory right? Is there really an ocean under there? And number 2, if there's stuff spouting out from the surface, they've got at least 3 instruments that'll sample that, and they can look at the chemical composition of that and see if there's organics there. If there's organics there in a real ocean that's under the surface, that gets pretty interesting, because it could support life. So that's the name of the game for that mission.
Who owns the observatory in Chile?
The one in Chile is National Science Foundation. That's the primary funding. There's also European funding in there. And Chile loves new telescopes. You know, Hawaii, man, it's hard to build a new telescope in Hawaii now because there's so many interests at work on these tall mountains that have, you know, interesting backgrounds as far as the indigenous people there. It's getting hard to get an approval to build a large telescope like that in Hawaii. Chile welcomes this stuff. They have, in that area, that particular area has a lot of tall mountains, and they have a lot of telescopes that have been built in there.
I realize Chile is a very long country and has lots of choices for latitude where to put this, but is there anything on the northern hemisphere that's equivalent to it, and what is the reason why it's in the southern hemisphere and not something in the northern?
Well, I just touched on that. We've been trying to build another giant telescope in Hawaii for years, and we've just had nothing. The astronomy community has had a very difficult time getting permits to build a large observatory like that on the top of a mountain in Hawaii. Well, there's a lot of things about Hawaii that are, we can go into some other time. New Mexico has an area where there's very favorable atmospheric conditions for astronomy as well. It's a little bit easier in New Mexico, but Hawaii is really, really good for observing. And the mountains are tall, they're 11,000 feet. This is 9,000 in Chile. So you got higher in the atmosphere, you got less interference, but you know.
Excuse me. I thought that part of the reason that the radiation was so intense in Jupiter was also, I think it had a rapid rotation that might be a factor. But I also was wondering, and I realize life can exist in, in amazing temperature variations, et cetera, but how would that intense radiation allow any life to possibly exist in there?
Well, if you get below the surface in Europa, you're pretty much protected from some of that stuff. So if you think about it, you'll be under that ice level, and there's still a live ocean underneath there. So I guess that's what they're thinking.
Any last question? One more. I got last question.
What part of Chile is this telescope? Is it in the top?
I don't know where it is on the map, but it's the Caltech. If you know Chile, you can tell me if that's a part of Chile. North, yeah, it's probably in the north.
So if Musk is planning to go there, maybe he won't be able to get back, as you said. That's A. And the other thing that I'd like to ask you is, if there's such a thing, and do you believe it's possible that there's extraterrestrials, are they watching us, or are we trying to watch them?
Good question.
They're watching us. Thank you, Bill. Join me in thanking Bill.